Here are your notes for lesson 4.3, triangles by sides. You will be able to classify triangles by sides and state and apply the triangle inequality theorem, which is what we're going to talk about now. So that theorem states that the sum of the length of any two sides of a triangle must be greater than the length of the third side. For example, looking at this triangle here, in order for this to actually be a triangle, the measure of the length of AC plus CB when added up has to be greater than AB. Okay, so what that means is if, say, AC is 4 units in length and CB is 6 units in length, right, then this AB would have to be over 10 units. It couldn't be equal to 10. It would have to be greater than 10, okay? So, again, if this is 4, 4 plus 6 is 10, the measure of this side or the length of this side would have to be 11 or greater, okay? So, again, AC plus CB, that sum has to be greater than the third side, and it has to apply to all three sides. So when you're testing it, you're going to need to literally test the sum of all three sides, and we're going to get into that when we do the try it out. All right, classifying triangles by sides. This is throwback information for many of us. Some stuff, most of this stuff should have learned in middle school, but if you haven't, here's a quick intro to it, and if you have, here's a quick recap. Scalene triangles, isosceles triangles, and equilateral triangles. A scalene doesn't have any sides that are congruent. An isosceles has at least two sides that are congruent. And an equilateral triangle has all three sides being congruent, okay? So as you can see here from the tick marks, these tick marks indicate that none of these sides is congruent to the other. So they're all different side lengths, all right? And so clearly side AB is not congruent to side BC, which is not congruent to side AC. All different lengths, and the measures of the angles inside are all different measures as well. An isosceles triangle has at least two sides that are congruent, okay? And in this case, it looks like DE and EF are our congruent sides. And so what that means is that the length of DE is the same as the length of EF. In an isosceles triangle, you'll have two sides that are of the same length. In an equilateral, and the word kind of gives it away, all three sides are the same in length, and all three angles are the same in length. And going back to isosceles, the angles that are opposite the congruent sides are congruent to each other. So angle D is equal to angle F. The measures of their angles are the same. Okay, and like I said, equilateral triangle, all three sides and angles are congruent, and since that's the case, they're each 60 degrees. So we know that there are 180 degrees in a triangle. If we split that into three equal angles, 60, 60, 60, and that's always the case with equilateral triangles. Okay, so that's that for that. This is kind of a shorter lesson, but we are going to get to this question here, and we're going to do this one together. The other two you'll do by yourself. I did give you a hint for the last one. Just read that hint and apply it, please. And it says here that a triangle has side lengths 8 and 3. Which of the following could be the length of the third side? So in figuring this out, I already deduced that 11 would not work. Why? Because if I take my three sides of my triangle, okay, and remember we said when you add up any two sides, that value you get has to be bigger than the third side. So let's consider, we're going to add up 8 plus 3, and is 8 plus 3 greater than 11? No, it is equal to 11. So that would not work, and that's why that answer choice wouldn't work either. Okay, so that's why that answer, you would have to throw that answer away. But let's test it with choice C. I'm going to go in this order. So we're going to take, again, 8, 3, and then if that third side was 4, would this work? So I'm going to take 8 plus 3. Is that greater than 4? Yes. Great. But now I have to test 3 and 4. Is that greater than 8? No. That wouldn't work. Why? Because 3 plus 4 is 7, and 7 is not greater than 8. So that answer choice, this one, would not work. This one would not work either. So let's test 6. 8, 3, 6. So I'm going to take 8 plus 3. Is that greater than 6? Right? Because I'm testing to see if it's greater than the third side. 8 plus 3 is 11, which is greater than 6. That checks out. And then 8 plus 6, because I got to test these sides too to see if they're greater than that 3. 8 plus 6, is that greater than the third side, which is 3? Yes, it's 14. Then 3 plus 6, is it greater than that third side? Yeah, because 9 is bigger than 8. So all 3 of them check out. Therefore, your answer is going to be 6, which is B. But let's test out 13. So again, I'm going to test it by adding up my sides and see if it's going to give me a number that's greater than the third side. So 8 plus 3 is not, right? I put the greater than sign for all of them, but it's not true. 8 plus 3 is not greater than 13 because 8 plus 3 is 11, which is not bigger than 13. So that means I don't really have to go through and test the other sides because this already rules it out as possible values of a triangle. Okay, and so that's that. A little bit more practice with that is probably necessary in order for you to master it. But we will. We'll practice tomorrow in class, okay? So make sure that you, and actually I'll leave this here just in case you guys are still copying it. Make sure that you do the second and the third, and those will be checked tomorrow. Stay tuned for 4.4, which is the video after this.